If you are here watching this video, you probably watched the first part of this, the inverted reactivity model of React, and you found it useful enough to check out the second video. And if you haven't, queue it up and watch it next. Now, there was a lot of feedback from that video, and one of the points that people brought up is, but you only showed Vue. And the reason for that is really simple. Vue is just a stand-in for other frameworks that are signals-based in their reactivity model. So this includes solid.js, for example, is signals-based. Preact has a signals-based option. And then, of course, Svelte. And what I find interesting about Svelte here in their docs is this first comment here: like every other framework, we've come to the realization that Knockout was right all along. And for those who don't know, Knockout is one of the predecessors of React and Vue. And I think it's really Vue is really the spiritual successor of Knockout. It was a really great framework, really useful, and at the time, one of the best ways to build reactive user interfaces. Okay, so that's in a nutshell why we can just look at Vue is really just the stand-in for these other signals-based frameworks. Okay. So let's look at one of the points that comes up in a lot of the discussions is, but the React compiler, right? What is the React compiler? Okay, so let's take a look, right? About almost exactly to the date, 2 years ago, right? Andrew Clark had this Twitter post. And he wrote, we might add a signals-like primitive to React, but I don't think it's a great way to write UI code. It's great for performance, but I prefer React's model where you pretend the whole thing is recreated every time. Our plan is to use a compiler to achieve comparable performance, okay? So if we unpack this, right, there's really 3 points to, that are encapsulated in the statement, right? Number one, it's great for performance. Signals like primitive would be great for performance. This is an admission that this model of using signals is probably better for performance, okay? But I prefer React's model where you pretend, right? So this goes back to our first video where we point out that React wants you to pretend that the whole component is recreated every time, right? And in fact, it's not, right? And let's look at our third statement here. Our plan is to use a compiler to achieve comparable performance, okay? So they believe that they can build a compiler that can achieve the same level of performance as a signals-based primitive, okay? Now, what exactly is this compiler? Is this compiler available? Is this compiler out 2 years later, 2 years on? Well, 2 years on, this compiler is still in beta. We are 2 years later, almost exactly 2 years later now, in February, and this compiler is still in beta. So in 2 years' time, they still have not shipped this compiler, whose goal is really to sprinkle in these memoization primitives to fix some of these issues. And we're going to look at what these issues are exactly when we dive into a little bit of code, okay? Now, one of the comments that comes up a lot is, but this really isn't a problem. Like, React works fine, it's great. Well, the problem is that, it really depends on what you're trying to do with React, who your target customers are, and what you're trying to achieve, right? So here is a open source set of benchmarks, and you can come in and configure the different frameworks you want to compare in these benchmarks, okay? And we can see we have here Vanilla.js, Solid, Svelte, Vue Vapor, Vue 3.5, Preact Signals, React compiler hooks, and React hooks. So this has the beta compiler connected to it. And let's see, does the compiler actually meet the promise of improving performance, right? And if you really just scan this, it's really obvious that again, these last 2 columns are React here, is that it's barely moved the needle for React. The performance improvements are really, really marginal. But we can see, of course, the memory allocation has somehow gotten a little bit worse. And to some extent, this makes sense. I don't know if this is definitely the case without looking deeply into how the benchmarks are written. but it makes sense, right? Because the way the memoization works is you're really trading memory pressure for performance, right? So instead of reallocating or recreating these objects, you're going to put them into memory and bring them back when you re-render the components, okay? So of course it makes sense that memory consumption will probably go up a little bit, okay? So you can see here, React, has it delivered on the promise of the improved performance that Andrew Clark had the statement here? Our plan is to use a compiler to achieve comparable performance. Well, if we look at these results, the answer is probably a resounding no. React isn't anywhere near delivering on those promises of improved performance. And you can look here, it hasn't decreased the uncompressed size, the compressed size of the package, the time to the first paint, it hasn't really moved the needle for React at all, okay? But let's step back for a moment and let's talk about what is this compiler supposed to do, right? The best article, I think, if you're really interested in what this compiler is supposed to do, is this article by Nadia Makarevic. And she has a series of really, really great articles on React and understanding the reactivity model, and also understanding, particularly this article, how this compiler is supposed to work and what it's supposed to solve. And her intro states it really clearly. The problem: re-renders in React are cascading. Every time you change state in a React component, you trigger a re-render of that component. Every component inside, components inside of those components, etc., until the end of the component tree is reached, okay? So this is the problem that the compiler is trying to solve by a process called memoization, okay? And to kind of help visualize this, we're actually going to jump into some code examples and look at what this really means, and why this is a problem for React and not a problem for any of the other reactivity models that use signals, okay? So we're gonna come back to this. Let's dive into our Vue example, okay? So here, again, I've used JS Fiddle so that it's easy for you to go in and load this up and try it out yourself. So you don't have to download any code. So what we've done here is we have a room component, and inside of our room component, we have a carpet, we have a sofa on top of that carpet, and then we have an occupant sitting on top of the sofa, okay? Then we also have a light component. That's our light up here. So you can see, here's our room, here's our light at the top of the room, here's our carpet, here's our sofa, and our sofa is currently occupied by Jeff, okay? Now, let's pop open the code too, is you can see here, this room component is just a setup function with a console log. We have our switch and our occupant. We have a function here to play musical chairs when we hit this button. And then we have this button to switch the lights on and off, okay? So what we're going to do is just play around with this, and let's take a look at what happens, okay? Number one is I'm going to run this sample, and you can see our room setup, light setup, carpet setup, sofa, and occupant setup functions all get invoked. The component function, setup functions get invoked right away when we render our tree, okay? Now, let's switch the lights. Keep your eye on the time. Now, as we switch the light, you can see the only time that's changing is this time. None of the other timestamps change because that part of the tree did not render, right? What if we toggle the music, right? We're playing musical chairs here. We toggle the music, and you can see these two components are updating their timestamps because they're part of the same tree here, okay? So because these two sets of components are in different trees, right? And because we are pushing props down to this subtree here, this subtree here with the carpet, the sofa, and the person sitting on the sofa, right? This subtree will update independently of this other subtree, okay? Because they are completely disconnected, right? Now, you can already guess that this is not the way that React works, okay? So I'm going to switch over to React, And in React, we have the exact same setup, okay? If you look at this room function, right, it looks almost identical to this, room component in Vue, right? They look so similar, right? We declare our use state here, just like we have our refs here. We have our musical chair function. And in fact, if we just move this down a little bit, it's gonna look even closer, okay? So let's move that down here. Okay, and look, these two functions, these two component trees look almost identical, right? Almost identical, okay? Now, in the React one, we have the exact same setup. We have our musical chairs function. We have the two buttons at the top. We have our room setup. Now, let's take a look at what happens when we run the example, okay? When we run, we have our room render, the light renders, the carpet renders, the sofa renders, and then the occupant renders, okay? Now, let's pay attention. When we hit the switch, let's see what happens, right? Okay, so we hit the switch, and guess what? All of these timestamps change. Every single one of these timestamps change. Why? Because the entire component tree just re-rendered. Well, you're thinking to yourself like, okay, well, Jeff actually didn't change. The occupant didn't change. Nothing changed about this subtree. Why did it update? It's exactly what Nadia says here, right? The way React re-renders work, it's cascading. It's going to re-render everything because it re-renders from the component function itself, okay? All the ways down, right? So here, when we hit the switch, because this is updating the state at the top level of this room here, it's going to re-render the children on both subtrees here, okay? And this is really, and you can see like this is a really simple application. And what happens is as the application gets bigger and bigger, this is what's happening in your entire application and why state management, for example, is really complicated in React, because what state management in React is trying to do is to prevent this from happening when you update state. It's trying to isolate the amount of renders that has to happen. So it's trying to slice the dependencies apart so that you don't over render, okay? Now, what happens when we, hit the musical chairs, right? You can see it does the same thing. Is we're picking a person, we're changing the person in the seat, but why is it updating the lights? Well, because it's the same problem. It's re-rendering the entire tree, right? And again, this is a really small example, so you're not going to really notice the performance difference. But you can imagine, again, a really large example where this could be problematic. Okay, so how do you fix this, right? That's the really important question, is how do you fix this? Well, the reason, the compiler exists is to help you fix this, because what the React team has realized is that this is a real problem, right? That developers can't really understand this concept and understand when to apply memoization and when not to apply it, okay? So let's fix it, right? If we want to fix it, what we can do is we can put const carpet here equals react.memo. So what we're going to do is we're just going to memoize this whole component function. And now here, the room is using this memoized component function. Okay, now let's run this again. Now if we run this and if we hit the music, right, you'll notice something is if we hit the music, our light is still changing, right? But if we hit the switch, our occupant does not change anymore. Okay, so we're now only rendering the room and the light. We're no longer rendering this subtree with the carpet, the sofa, and the occupant. Okay, so again, if we hit this one, you can see we are re-rendering effectively the whole tree here. But if we hit this button, we now, because this is memoized, right, this component here is memoized, we are only rendering this part of the subtree, okay? To completely fix this, we have to fix both of these, right? Const light equals react.memo. Okay, so now let's run this again. Okay, so here, this is what we expect. And here, this is what we expect, because now the lights are not rendering, okay? So this is the core challenge that the core problem that the React compiler is trying to solve for, is developers will do either one of two things, right? One is they will not memoize enough in the React application, okay? And that causes a lot of over-rendering and performance problems, right? Or two, they are going to over-memoize, go the other way and just say, okay, wait a second, this is terrible. We should just memoize everything. They're going to go the other way, and they're going to over-memoize and consume too much memory when they didn't need to memoize, okay? So this is the real challenge that the compiler is trying to solve for. Is it's trying to automatically introduce these memoization primitives into your application. It's not just React.memo, but also use memo and use callback to make sure you don't over-render when you don't need to perform the rendering, okay? So these examples are going to be down below in the description, so you can take the links and just play around with them yourself in JS Fiddle. And I think it's a really great education tool, especially if you're really used to working in one framework, like you're really used to working in Vue and not in React, or you're really used to working in React and not in Vue. You can get a good idea of how these two worldviews of how reactivity works in the browser are just so completely different. Okay, let's come back to this, right? But React is just better, right? This comes up all the time. Is React is just better? Is it better? That's hard to say. I think it really comes down to preference. I think at this point, what's really challenging is that a lot of the React has won the web framework wars, right? There's no question about that, right? But the problem is that this reactivity model is really painful, actually. It's really hard to grasp and do it correctly. A lot of people think that it's just fine. Like, I don't need to do this memoization, but you are actually doing React wrong. And that is the purpose of the compiler. The compiler that they've been building for 2 years, the reason they're building it is because too many people are doing React wrong. They think they are doing it right, but they're doing it wrong because they don't understand the reactivity model at the very core, and they don't understand how to manage the state of the application from memoization, where to put state, when should I use memo, when should I use callback. Developers do not understand this, and that is why they are building the compiler, because the compiler should fix this so that developers don't have to think about it, okay? Now, is React better? I would say that it is this compiler is an admission that this is a bad design, right? To me, it's kind of like admitting that we made a really bad design decision, and let's try to fix that design decision by just throwing in memoization into the application, right? When in fact the team knows, right? The team knows that using a signals-like primitive is great for performance, right? They know how to fix this, okay? But they won't fix it because who knows, right? I think it'd be great if they fixed it, because we, by and large, web developers, we're all kind of forced to either use React, and of course, we have to consume React-based applications every day. So I think for all parties, it would be really great if the React team would just go in and fix this, right? Now, let's come down to our final point. I mean, if Vue is so great, why isn't it more popular? This one is just really hard to answer. I don't think there's one answer that, why Vue isn't more popular. But I would say that it's probably the case that it's not that Vue is not popular for any specific reason, but as I wrote in this, this Medium post years ago, the problem that we have now is that while React is popular equals true. And one of the reasons this is the case is that people are kind of afraid of picking a platform that's not the dominant one, right? So the title of this post is React is the New IBM. And people that are familiar with the era of computing before Microsoft know what this means is, by default, if you were a IT decision maker, you would just buy IBM. Why? Because you'll never get fired for picking it, right? Even if it's expensive, the project is terrible, the consultants are, just terrible, they don't know what they're doing, and the end result is just complete and utter trash, right? You will never get fired. In that era, you would never get fired for picking IBM. Why? Because you would just say, look, I picked IBM. How could I have known that it would go wrong, right? So React is kind of, in my opinion, is in a similar boat, is that React is popular because people pick it. It has a great ecosystem for sure, but people pick React because they will never be fired for picking it, right? The moment you run into a speed bump with, let's say, Vue or Solid or Preact, right? Somebody is going to complain and they're going to blame you, right? So this, I think, is one of the reasons why React is so popular, is that it's the new IBM, right? It's the kind of safe default choice that teams pick, even though it is objectively a really bad performer and really bad choice. And we can see that the React team has continued to make like bad decision on top of bad decision, right? So instead of coming in here acknowledging that signals-based reactivity is better for performance, and hey, why don't we just make React signals-based, right? Why don't we just change where we're pointing our reactive callback instead of pointing our reactive callback all the ways up to the component function? What if we pointed our reactive callback just to the function, the reactive function itself, okay? Or we use signals to do that. They could fix it, but they chose not to fix it, right? And here we are 2 years later, and the compiler is still in beta, okay? So I don't know. I think, I think that it would be a great service to the entire web dev community if the React team would really just take a step back and say, look, what if we did take a signals-based primitive approach to rebuilding or refactoring React, and everybody just got the benefit of better performance, right? So I hope that you found this second video also really useful and helped you understand, really the scope of why this is problematic with React. Again, this is not the purpose of this video isn't to say React is better or Vue is better or React is trash or Vue is trash. That's not the case. I think it's really important for developers, either you're already a React developer and you already know all this information, great. What may be useful for you is to understand that this doesn't happen, the problems that React has doesn't happen in any of the other frameworks. They're really unique to React, okay? And for Vue developers, I think, if you've always felt like React doesn't quite feel right, or Svelte developers, you really love Svelte, right? And you don't really understand why. I think this is probably the reason why, is because this inverted reactivity model that you have to work with in React just doesn't make any sense, right? You actually have to contort how you think about JavaScript's execution model to be able to effectively and correctly use React, okay? So hope you found these two videos helpful, and leave a comment, like, and subscribe for interesting, deep dive technical videos like these. And we'll check you next time.